Today we'll start with aromaticity. So the compounds that follow, there are a few rules for aromaticity. The compounds that follow are the compounds that follow the following rules, I can say, or which the compounds that satisfy is better word, satisfy the following criteria are aromatic compounds. Aromatic compounds. Okay. So the first criteria is that the structure should be planar. Molecule should be planar. What does that mean? It means there should be no sp3 hybridized carbon. sp3 hybridized, or you can say there should be no tetrahedral carbon or the carbon should be either sp2, that is trigonal planar. It should be planar structure. Molecule should be planar. Second is there should be resonance, and the delocalization should be complete delocalization. There should be complete delocalization of pi electrons. Complete delocalization of pi electrons. Now, it means that after you have checked the planarity, you will check that whether the molecule is complete ring or not. Okay, if it is ring and all the atoms are sp2, then it will be having a complete delocalization. Okay, next is third point. It should follow the Huckel rule. What is the Huckel rule? That it says that the number of pi electrons should be equal to 4n plus 2. That means it should satisfy this criteria of 4n plus 2, where n is equal to, now this n does not mean number of pi electrons. Okay, so right now I suggest that you write these three things. Okay, you write these three things as of for today. You write the notes. Okay, aromaticity ke liye, because we'll be using these criteria to detect what is aromatic and what is not aromatic, where n is equal to 0, 1, 2, 3, etc. This, the last point, this is known as Huckel rule or Huckel's rule. Okay. The last criteria, 4n plus 2 pi electron. There should be 4n plus 2 pi electrons, where n is equal to 0, 1, 2, or 3. N is not the number of pi electrons. You write these 3 points. Don't think of it so much. Don't think. The way we define things and the way we approach the problems, they are sometimes quite different. And you will see the same thing happening in aromaticity. You write these 3 as it is. They will help you. But dil pe nahi lene ka abhi isko. Please let me know if you're done. If you're done writing these 3 points. Please raise your hand if you're done. Waiting for Hamza, Hiba, Khalid, Zainab. Okay. So now we will do some examples. Okay. Okay. Now you can stop. Yeah. You can lower your hands now. You can lower your hands. Read the question. Identify the aromatic compounds. Aromatic compounds. Okay. Now, the first molecule is cyclohexane. Now you tell me, Acha, how many of you have a slight difficulty in telling sp3, sp2? I say like you. I hope all of you can say na. If I just draw a line diagram, you can say na which carbon is sp3, which carbon is sp2. Yes or no? Hamza?
Yes,
Just
sir,
by
I can
looking,
tell.
you can tell. Okay, Sarah, Samaira.
Yes, sir.
Yes, okay. So tell me, first thing you will check, is there any sp3 carbon? If sp3 carbon is there, है ना? You will get either yes or no. So let us say you get yes or you get no. So tell me, is there any sp3 carbon? Tell me, is there any sp3 carbon?
No.
There is no sp3 carbon. What about Hamza? What do you think? Hamza, आपको बोले तो बता देंगे. क्या हो गया? Hamza, is there any sp3 carbon?
No.
No. Okay. What is the hybridization here, Samaira? This carbon?
sp2.
sp2. बहुत ही बढ़िया. यही हम बोल रहे थे. आप लोग को ये भी नहीं पता है कि हमको क्या नहीं आता है. So how do we check hybridization? क्या देखते हैं हम लोग? Hybridization के लिए क्या देखना होता है? What do we see for hybridization? What do you see? You tell me. हमजा बताइए क्या देखते हैं आप? What do you see?
So the steric number.
Steric number. What is the steric number? Steric number क्या होता है? Number of steric number आपको यहाँ से थोड़ी ना पता चल रहा है. In molecules we don't write steric number ना. क्या लिखते हैं हम लोग? What is steric number is equal to? Here तो you can only see bonds. So in terms of bonds आप बताइए ना, what is steric number? अरे टेल हमजा, आपसे ही पूछ रहे हैं. हमजा बताइए. No idea. Samaira, what is steric number? How do you see hybridization? How do you tell the hybridization, Samaira? Yes, Samaira, how do you tell the hybridization? Please don't waste time. Samaira, can you please turn the mic on and tell me?
So by seeing the bonds.
By seeing the bonds. What do you see actually? You tell me. क्या देखते हैं by seeing the bonds? कितने bonds है इस कार्बन के पास? बताइए तो. How many bonds does this carbon have?
2.
2. इतना समझाया है आप लोगों को कि यहाँ पे हाइड्रोजन जो है इम्प्लिसिट है ना. हाइड्रोजन है ना यहाँ पे कि नहीं है हाइड्रोजन? How many hydrogens all of the carbon has?
2.
4 हाइड्रोजन. सबको 4 हाइड्रोजन है. सारा कहाँ है?
2 hydrogen.
2 हाइड्रोजन्स. हाँ तो ठीक से बोलिए ना. Either you say it properly. हाँ 2 हाइड्रोजन्स. So what is the steric number, guys? आ रहा है कि नहीं आ रहा है? Turn the mic on. Hamza, Hiba, Hishma, Khalid, Salman, Samaira, Sara, all of you. How do you know there are 2 hydrogens? Tell me, Hamza. How do we know there are 2 hydrogens?
Because carbon can make 4 bonds and 2 bonds are already there. Like two bonds are made with carbon and the other 2 will be with hydrogen.
ध्यान रखिए ना, ये भूलने वाली चीज नहीं है. ठीक है. You can't afford to forget this. You will get everything wrong. You'll get everything wrong. Okay. So what is the steric number here?
Four.
So hybridization is
sp3
है ना. तो sp3 है. खालिद आपको आया?
यस सर.
आप लोगों को ना मार लगनी चाहिए. मार पकड़ के बिल्कुल लगनी चाहिए कि नहीं लगनी चाहिए आप लोगों को मार. हाँ. हाइब्रिडाइजेशन आप लोग नहीं बता पा रहे हैं. यू आर नॉट इवन मतलब रिमेंबरिंग अबाउट हाइड्रोजन्स दैट आर इम्प्लिसिट इन बॉन्ड लाइन स्ट्रक्चर्स. So will this be aromatic or not aromatic? So whenever you have sp3, if sp3 carbon is present, है ना, then it will be not aromatic. Or also there is no pi bond, so pi bond should be there for aromaticity. Resonance होना चाहिए for aromaticity. Okay. Second, hybridization बताइए सब में आप. 1 2 3 4 5 6. Hybridization बताइए क्या हो गया? For the first one, tell me what is the hybridization, Hamza?
So sp2
Second one,
sp3
देखते हैं. Second one, अच्छा. How many hydrogen does the first one have?
2
And how many hydrogen does the second one has?
so 1
So second one has how many sigma bonds? Second one has how many sigma bonds? Huh? How many sigma bonds total? CCCH सब मिला के. Second carbon has how many sigma bonds?
so 4
4 sigma bonds. कहाँ से 4 sigma bonds दिख रहा है आपको? ये एक हो गया, ये 2 हो गया, ये 3 ही तो है. तो पाई बॉन्ड ना.
Sir, your voice is lagging.
So my voice is lagging. I'm asking. You said 4 sigma bonds, right, Hamza? Where's my voice now? Is it better?
Sir, my network was unstable.
Achha. For others, it is fine. Samaira, can you hear me?
Yes, sir.
Okay. Good. So steric number is will be equal to 3 ना हमजा. 4 बॉन्ड कैसे दिख रहे हैं आप लोगों को? सिग्मा पाई बॉन्ड में तो मत गलती कीजिए. क्या ही पढ़ाएंगे फिर हम आप लोगों को? If you can't get the sigma and pi bonds correct, what I will teach you? You will figure this out. Okay, I'm just teaching you today. आप लोग notes लीजिएगा and you will figure this out. I'm not going to make you understand anything today. ना, you will figure this out. Aromaticity हम पढ़ाएंगे. उसके अलावा whatever backlogs you have created for yourself, now you can't identify the number of bonds, you can't identify the hybridization, that you will clear it up. Okay, today I'm going to teach it. Aromaticity I have to complete. You will figure out the hybridization, you will figure out the pi bonds, you will figure out the sigma bonds. Now in this case, I'm not going to ask questions now. In this case, all the carbons, they are sp2. All the carbons are sp2. But here we can see that there is not complete delocalization because absence of ring. Absence of ring. So ring should be present and all the carbons should be sp2. There should be no sp3 carbon. There should be no sp3 carbon. Let us look at the third structure and understand. Now in the third structure, we have a cyclopropane. There's a pi bond here. And then we have the lone pair here. Then we have the lone pair here. Now this can be also written as like this. Okay, so this negative charge, it means that there is non-bonded electrons, lone pair electrons, non-bonded electrons. Now in this case, we will first of all identify that this is what sp2, this is also sp2, and this only has 3 bonds. That is why this will be also planar. This will be also planar. So the complete structure is going to be planar. And also, if you make a triangle, triangle cannot be of 3 dimension. You can only make triangle in a 2D space, only in a 2D space. Okay. So all of these are planar. So it is what? It is cyclic. It is planar. Right? So cyclic and planar. First 2 conditions are fulfilled. Now we will look at the pi electrons. So number of pi electrons. Number of pi electrons means all the electrons that are participating in the resonance. All the electrons that are participating in the resonance. So you can see negative sign here. So this negative sign will go here. Pi bond will move here. So you can write the resonating structure like this. This is negative charge here. The pi bond is here now. Then you can move the negative charge here and then move the pi bond to the next carbon atom, and you will get the negative charge here and the pi bond here. Now you can move again this pi bond here, and the negative charge will go on the first place. So we have got complete delocalization. We have covered all the carbon atoms. See the first, this carbon atom, then you have this carbon atom here, which is also getting negative charge. This carbon also is getting negative charge. So all the carbon atoms is getting negative charge. All the bonds in the cyclic planar structure, they are going to and fro from double bond and pi, double bond and single bonds. So there is pi bonds delocalization is complete. So we have complete delocalization of pi electron. So that is given by the planar structure. Now number of pi electrons. Number of pi electron is how much? So we have this negative charge. It is converting into pi bond, and this pi bond is also converting into negative charge. That is why 2 plus 2 we have 4. How 4? We have 1 pi bond plus 1 lone pair. Lone pair. So from pi bond we will get 2 electrons. From lone pair we will get 2 electrons. So it is equal to how much? Total of 4 electrons. Now, when you have calculated the number of electrons, you will write this equation 4n plus 2. It is equal to the number of pi electrons, 4 electrons. Now you will calculate what is n. So n will be equal to, let us write 4n. It is equal to how much? 4 minus 2. So n will be equal to 2 by 4, which is equal to 1 by 2. Now, according to Huckel rule, n should be equal to how much? 0, 1, 2, or so on. But now n is not equal to these whole numbers. That is why this structure will be not aromatic. The structure will be not aromatic. So it it got the criteria of cyclic and planar, but the number of pi electrons, it violated the Huckel rule. That is why this structure is not aromatic. Let us look at another structure, D. Now, this structure we can see it is a ring. We can say that it is cyclic. It is planar. Why planar? This also has all these carbon atoms are sp2 hybridized, and you can also draw the resonating structure, and you can show that all the bonds are participating. All the carbons are participating in the resonance structure. All the carbons in the cyclic planar structure. Okay, so you are getting pi bonds here now. It is delocalization is also there. Delocalization. Now, the next criteria is number of pi electrons. So number of pi electrons is equal to, there is 2 pi bond. That means 2 into, in one bond there is 2 electrons, so which will be equal to 4 electrons, which will be equal to 4 electrons. And again, we need to satisfy the Huckel rule. So Huckel rule says 4n plus 2, which is equal to 4 electron. Now here we find the value of n. So n again it will be equal to 1 by 2. And that is why it is not aromatic. Why? N should be 1 or 0, 1, 2, 3 or so on. N should be whole number. And since n is not a whole number, it is not aromatic. It is not aromatic. It is not aromatic. Okay. Let us look at this structure. A positive charge here. Okay, and a positive charge here. Now, this structure is also, this is also sp2. This is also sp2. And this is also sp2. So it is cyclic. It is also planar. Now we just have to look at the number of pi electrons. So number of pi electrons is equal to, so we have only one pi bond. This is positive charge. So positive charge does not have any electrons. So number of pi electrons is equal to how much? 2 electrons. There are 2 electrons. Now we'll look at the Huckel rule. 4n plus 2. It is equal to 2. Hence 4n is equal to 2 minus 2. N will be equal to 0. Right? So when n is equal to 0, it is a whole number. That is why this will be aromatic structure, because it follows all the criteria. It's going to be aromatic. Another structure you can see is the famous benzene ring. So in benzene ring also we have this cyclic. All the carbon atoms are sp2. That is why it is planar. Now the only criteria is checking the pi electrons. So pi electrons is how much? We have 3 pi bonds. Now in each pi bond we have 2 electrons, so 3 into 2, which is equal to 6 electrons. Now we just need to check the Huckel rule, that is 4n plus 2, which is equal to 6 electrons. Now n will be equal to 4n, it is equal to 6 minus 2 electrons, which will be equal to 4n is equal to 4. So n will be equal to 1. So yeah, we have got 1 as the number, 1 as a whole number. That is why it is following the Huckel rule and it is aromatic. And this is also going to be aromatic. Okay. Now, aromatic. Now, in these questions, we have to explain why the following systems are not aromatic. Why are following systems not aromatic? Okay, number 1, let us look at the structure. CH2, and we have pi bonds here and pi bond here. Now, in this structure, we can easily identify that this carbon atom is sp3. This carbon atom is sp3 carbon, and that is why it is not a planar structure. Not a planar structure. Next is again here also we can identify that this carbon is sp3, and that is why not a planar structure. And also you can see that it is complete delocalization is not present. Okay, delocalization. Complete delocalization is not present. Third is if you have something like this. Now here we have the pi electrons like this. Now, this structure, all the carbon atoms are, it is cyclic, we can see. All the carbon atoms are sp2, and it is planar also. Let us look at the pi electrons. The number of pi electrons will be equal to 4 times pi bond. Now each bond has 2 electrons, so 4 into 2, which will be equal to 8 electrons. So we have 4n plus 2, that is the Huckel rule. It should satisfy the criteria that n is equal to 0, 1, 2, or 3. Okay, that is the whole number, any whole number. Now 4n, in this case, it is equal to 8 minus 2. So n will be equal to 6 upon 4, which is equal to 3 by 2. Now in this case, we can see that n is not equal to whole number. That is why it is not aromatic. Why? Violates Huckel's rule. It violates Huckel's rule. Tell me, is this clear? Yes or no? Is the aromaticity clear?
Yes, sir.
Okay. Next is
Yes,
the
sir.
preparation of benzene ring. Preparation of benzene. Preparation of benzene. So there are 3 methods of preparation of benzene. So one method is from alkynes polymerization. So if anyone wrote the polymerization of alkyne, there was a linear polymerization and cyclic polymerization of alkyne. So in that, let me just tell you one more thing. In aromaticity, that if you have this type of structure, no, like for example, you have benzene ring, and there is a CH3 group. Please don't tell that this is sp3. इस वजह से नहीं होगा, है ना? You have to look at the cyclic planar structure. So this structure is what? This is aromatic. So if any molecule has a certain part which is aromatic, then the whole molecule is said that it is aromatic only. It is aromatic only. Okay. And if you have benzene ring which are fused together like this, then also both these rings are aromatic. That is why this is also aromatic. Okay, this is the structure of naphthalene. The naphthalene balls that we have now, this is the structure. Okay, preparation of benzene. So the first preparation is with ethyne. You take a lot of ethyne molecules, that is CH triple bond CH, and you pass it over a red hot tube, like very hot tube. Okay, red hot tube. Next method of preparation is from the sodium salt of benzoic acid. So in benzoic acid, you will just add NaOH and you will get COONA, which is the sodium salt. And if you keep that in some more NaOH and calcium oxide, apply some heat, then you will be getting benzene ring. Next is if you have phenol, and in phenol you just add zinc dust, you will be getting benzene ring. So these are the three methods of preparation. These are the three methods of preparation. Here you have zinc dust. You just add zinc to phenol, you will be getting a benzene ring. Will be getting a benzene ring. So there are only three methods of preparation, nothing else. Next is the physical properties. Next is the physical properties. Now, it is non-polar. That is why it is non-polar and hence not soluble in water. It is not soluble in water. Next is, it is usually colorless, does not have any color. Next, you must have smelled naphthalene bonds. They have some characteristic, you can say, smell or aroma. So it has some particular smell. You can't say it is pleasant. For some people it is pleasant, for some people it is not pleasant. So characteristic aroma, that means you can identify just by smelling aromatic compounds. Now it is immiscible in water, but it is soluble in non-polar solvents such as ethers, hexane, octane, etc. Okay, hexane, octane, etc. So these are the physical properties of benzene. Okay, nothing much here. Main important point of benzene is in the chemical properties. So first thing is that benzene, it has 3 pi bonds, right? If you look at benzene, it seems to have 3 pi bonds. So the chemical properties. Now in chemical properties, this is benzene ring, and we know that it will show resonance, and the pi bonds are like this, alternate pi bonds. The resonance hybrid structure for both of them. So this is the real structure. Okay. Now, even though in the resonating structures, we can see there are complete pi bonds, but in the resonance hybrid structure, we see that there is no pure pi bond. And if there is no pure pi bond, then it will not behave as alkenes. It will not behave as alkene. So due to the absence of pure pi bonds, benzene ring doesn't show characteristic reactions as that of alkenes. So obviously it is nothing like alkene. And initially when scientists saw this C6H6, so they had in their mind this figure, that is benzene with alternate pi bonds. So they treated this with Br2, Anna. So Br2 is brown in color. They expected that just by treating it with Br2 in dark, they expected that there should be some reaction happening, but it did not show any reaction. Okay, so generally benzenes, they don't show any type of any addition reaction. Okay, so benzene don't show, benzene doesn't show addition reaction. And addition reaction is a characteristic reaction if there is pi bond available, but here we don't have any pure pi bond. Also, the C single bond C Okay, C single bond C, it is of 154 picometers, and the C double bond C is of 133 picometer, and the CC bond in benzene was found to be 139 picometer, which is between the single and double bond. That is why now this measurement and this value also suggests that the bonds between carbon and carbon in benzene, it is what? It is partial double bond character. It has partial double bond character. So all the CC bonds in benzene have partial double bond character. Partial double bond character. Okay. Is this clear? Yes or no? Please tell me.
Yes.
Okay. So next is a series of electrophilic aromatic substitution reactions. Okay. So benzene, they particularly show electrophilic aromatic substitution reactions. So there are 5 reactions that we have to learn. Let us do at least one today. We will do one today, and then we'll leave the rest of them for the next class. Electrophilic aromatic substitution reactions. Okay. In electrophilic aromatic substitution reaction, let's first of all start with nitration. I'm giving you the reaction, then we'll write the mechanism also. So benzene ring, when treated with HNO3, it is going to give me nitrobenzene in the presence of conc H2SO4. It is going to give me nitrobenzene. So benzene ring with a NO2 group attached to it. With a NO2 group attached to it. Now, how is the mechanism? So the mechanism goes something like this, that we have HNO3 and H2SO4. So the structure of H2SO4 is sulfur, double bond oxygen, OH, OH. So there is 1 sulfur, 4 oxygen, and 2 hydrogens, H2SO4. Okay. Now, plus we have HNO3. So HNO3 is nitrogen with a OH bond, and a double bond oxygen and a dative bond oxygen, like this, coordinate bond oxygen. Now we know that H2SO4 is more acidic. It is more acidic. So this will be acting as acid. This will be acting as a base because we have lone pair electrons here. So this lone pair electron will attack on this hydrogen, and we will be getting here, we will be getting HSO4. 1 hydrogen is being left, and you get the conjugate base of acid H2SO4, HSO4 negative. Plus in the in HNO3, we get this structure, hydrogen which is bonded to oxygen. This oxygen get 1 more hydrogen from the H2SO4, and this will get a positive charge. Plus you will have nitrogen doubly bonded with oxygen and a dative bond, that is coordinate bond with oxygen here. Now as you can see, this oxygen is what? Positively charged. This bond will break and you will get H2O plus NO2. Now this NO2, since it has lost a bond, it will have a positive charge. Okay. Next step is, this is the formation of electrophile. So this is the electrophile that we have, an electron deficient species. Next step in the mechanism is the attack of electrophile on benzene. So benzene, which is electron rich, so let us focus on these hydrogens here. Okay, And then we have NO2 positive. So any one of these pi bonds will attack on nitrogen. And then you will be forming. Now, when the pi bond is attacking either this carbon or this carbon, any one of the carbon will get the electrophile. So let us draw it like this. These pi bonds are intact, nothing happened to them. Let us say that this hydrogen is here and this carbon got the electrophile and it also has the hydrogen. So initially also it had 4 bonds, now also it has 4 bonds, but this carbon, it initially had 1, 2, 3, 4 bonds, now it has only 3 bonds. That is why this will get a positive charge. This is going to get a positive charge. Now, this is known as the arenium ion. This arenium ion is stabilized by resonance, you can see. Here we have the E and H. There will be pi bond here. Get the positive charge here. The pi bond will be here. Then again, you can see that it is the carbocation that we have here. It is stabilized by resonance. Now, let us take this structure here. Now we have the HSO4 negative, HSO4 negative. Now this HSO4 negative will act on attack on this hydrogen because it is negatively charged. It will abstract the H plus ion and the electrons of this bond will shift to this bond here, and you will be getting. अच्छा, ये E जो हमने लिखा ना, that is NO2, okay. Electrophile, that is NO2 only. I represented that by E is NO2. The bond here with 2 bonds here, and the NO2 is attached on the benzene ring, so you get a nitrobenzene. And the H2SO4, which has been used as catalyst, it is produced in the product also, so it can again act. It can again act in the reaction and generate nitrobenzenes. Okay, again generate nitrobenzene. So we have 3 steps here. First is the first step here. It is known as generation of electrophile. This step is known as formation of carbocation. That is the arenium ion. Last step is loss of proton. So in all the electrophilic aromatic substitution, there will be these three different steps in the mechanism. The formation of carbocation and loss of proton will be same in all of them. There will be only difference in the generation of electrophile. There will be different electrophiles which will be generated. Now, if you want to see what is the electrophile, then you just look at the group. So in nitration, what is the electrophile? NO2 positive is the electrophile. Okay. So the electrophile here, the E is what? What is the group added? NO2. You just give a NO2 positive sign here. This is going to be my electrophile. Okay. This is going to be my electrophile. Is this clear with everyone? Yes or no? Is this clear? Yes or no?
Yes, sir.
Yes.
Okay. Now let me give you some questions for aromaticity.